I'm going to do as many problems as I can do from now until a quarter after. And then a quarter after, I'm going to set you loose, and you're going to work on your own. Is that fair enough? We've got to go over this stuff. Tomorrow we're going to finish up this section, this whole unit. What's today? Today's Thursday, tomorrow's Friday. Probably Monday, probably Tuesday next week, you're going to have a unit test on all of this polygon stuff. All of this right here, all of your parallelogram stuff. We got to move on, okay? And we're going to move on. Now, you got it?
Yeah.
Okay. Okay. Let's look at number 1 on that page. All right, it says, tell whether each figure is a polygon. So number 1, you've got this figure that looks like this, something like this. Is that a polygon, yes or no? Yes, why? 6 straight sides. There is no overlap. It is not curved. And then the last part, it says, if it is a polygon, name it by the number of sides. Hexagon. 6 sides is a hexagon. All right, number 2 looks like this. Is that a polygon? No. Why? Curves. It's not a polygon. It curves. Write this down. I'm not doing this for my health.
You have to write it last.
I would, if it were me. It looks something like this. Now that looks like the UTT. Kind of, sort of. Nothing. Okay. That looks like University of Tennessee T. Kind of. That's a bad drawing. Is that a polygon?
Yeah.
Yeah, it is a polygon. All right, now I'm not sure. I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 sides. What's a 12-sided figure? Dodecagon. Very good. Dodecagon. Hey, by the way, just to take this one extra step, is that convex or concave? Why is it concave? Because it looks like it's been punched. It looks like it's been caved in, doesn't it? Looks like somebody got mad at it and punched it right in his face. All right, what about number 4? It says tell whether each polygon is regular or irregular. Tell whether it is concave or convex. That looks like an arrow. I can't look at it upside down. Oh, it's flat on the bottom. So it looks like this. That's bad. Ooh, that's bad. All right, first of all, is it regular or irregular? Why? It's got all these sides congruent.
It's not. It's convex.
But it's convex, and regular polygons have, no, is that convex? It's concave. All right, so it's irregular. Okay. Because it's concave, and what has to be true? If it were regular, then all the angles would have to be what? All of the angles are congruent. All these angles are not congruent, are they? Well, I see them. This one appears to be acute. Do you guys agree with that? This one up here definitely appears to be obtuse. So my angles do not go together at all. Let's look at number 5. Number 5. It does look like a plus sign. That is beautifully made. All of the angles are right angles. What's all of the sides? All of the sides are congruent. And clearly my picture looks perfectly made. Don't make fun. Is that regular or irregular? What is it? It is irregular. Why? because it's concave. Regular means, and you should have it on your paper. Regular means that every side is congruent, every angle is congruent. Okay, all right. Irregular because it's concave. Look at 6. Number 6. I like number 6. Why is that one regular? All sides are congruent and all angles are congruent. So this is a regular quadrilateral. It's convex. And if it's a regular quadrilateral, especially after what we've gone over the last 2 days, what kind of quadrilateral is a regular quadrilateral? This is square, right? Questions? Comments? Rude remarks? I can take it. Back at you. Here we go. Here we go. Let's look at, what is it, 7? Yeah. 7, we're changing gears. It says find the measure of each interior angle of pentagon ABCDE. I would add them together, but would I add it to 180 or 360? Well, how do I find that sum?
You subtract it by 2 and make it 1.
Ah, what's that formula? And how many sides does a pentagon have?
5.
So, here we go. 5 minus 2 times 180 is 3 times 180, which is 540. Do you guys agree? Am I going to divide by 5? When's the only time I'm going to divide by 5? If, say it again, Daniel. If all of the angles in that pentagon were congruent, then I would divide by 5. Nope, because this is the sum. Okay? The sum of that pentagon's interior angles is 540. What is, in this picture on page S14, what is the measure of angle E? We don't know yet. We got to find it, don't we? How are we going to find it? Add them all together. All right, so here's what we're going to do, and this is going to take us a while to write out, but we're going to write it out anyway. This is pentagon ABCDE. Which is equal to the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E. Write that down. Write it down. Exactly what I'm writing needs to be on your notes. Pentagon. We found that the sum was equal to how much? 540. We figured that out right off. What is the measure of angle A? 3x. What's the measure of angle B? What's the measure of angle C, Lauren? And the measure of angle D? Minus 15. And the measure of angle E. Do you guys buy that? Yeah? Combine like terms. Now, is the geometry over? Geometry is done. What takes over? Now algebra kicks in. Okay? So we've got to add all of our like terms. If I add all of my x terms, I get 3, 4, 5, 6, 7, 8, 9, 10x, right? 20 plus 5 is 25. Minus 15 is positive 10. Solve that for x for me real quick. How many of you got 53 for x? Now, where's that going to be on our SOL test? It's going to be the very first answer you're given. Okay? Go back and read the question. Find the measure of each interior angle. What in the world? Now I have to go back and plug them all back in. All right, now here's the thing. If you remember what just happened, if you remember, here's an angle 3x. Here's an angle x plus 20, 2x plus 5, 2x minus 15, and then 2x. Those are our 5 angles that Lauren called off for me, right? What am I going to do with 53? I'll go back and plug it in. You guys have your picture in your book to look at. What is 3 times 53? No. Is it 159? Yeah, it's 159. So it's 159. 53 plus 20 is 73 degrees. 2 times 53 is 106. 106 plus 5 is 111. 2 times 53 is 106. 106 minus 15, is that 99? 106 or 89? Okay, what was I thinking? And then 2 times 53 is 106 degrees. What? Does everybody understand where I got those values? Okay. What better happened with those values I just wrote up there in black? They better equal 540 degrees, do they? Yeah. Take 159 plus 73 plus 111 plus 91 plus 106. It does. Hallelujah. So I know that I have the correct angle measures. Do you guys agree? Yeah. Okay, here's the thing. If you're not keeping up with me, then what do I expect you to do? Or watch the video, okay? All you have to do is say, whoa, wait a minute, Miss Perry. Whoa, hold up. I'm not with you, okay? Whoa, hoss. I will respond to that. I expect you to have this in your notes. I expect you to know this by Tuesday of next week if you don't already. You got a whole bunch of stuff. We will get through the majority of the material. We will get through it before you take that SOL. Number 8, we're there now. Oh, what's number 8 say? Find the sum of the interior angle measures of a convex heptagon. The sum of the interior angles, that's exactly right, of a heptagon. And you said a heptagon has how many sides, everybody? 7 sides. N minus 2 times 180. 7 minus 2, which is 5 times 180, which is 900? Nah, that can't be right.
That's right.
It is?
Yeah.
Question? You writing this down? Questions? How about 9? Find the measure of each interior angle of a regular 15-gon. Why? Each interior angle of a regular 15-gon. What's the key word to show me or tell me that I'm going to divide? Regular. Every time you see that word, you ought to go above it and draw a division symbol. How are you going to go about finding this? I got to find the sum first. Once I find the sum, I'm going to take that sum and I'm going to divide by 15. Hey, you do that on your own. Don't. So how many of you got 156 for each of those interior angles? Very, very good. All right, it's a quarter after. So what are you going to do? You're going to keep working. Just FYI, we just finished number 9. Number 10 says find the value of x in polygon FGHJKL, which is over there to the right. Let me just ask you something. What kind of angles are you looking at there? Exterior angles. What's my magical exterior number? 360 degrees. So what are you going to do with all of those exterior angles? Add them together and set them equal to 360. Folks, you do that yourselves, and I want you to complete the rest of that assignment at home for tomorrow. Because it's exterior angles. You have to know. If we're dealing with exterior angles, we're dealing with 360 degrees total. Okay? Work on that